I'm the technical director of Envotherm. Envotherm is about pure business. We clean water, and we clean water with the lowest energy consumption. We make the water about 50% cleaner of any of our competition, and we like to think that we do it the smart way, efficiently. We can clean water to 1/80 of what it costs to evaporate directly. And the way we do that is simple, by using smart engineering and a little bit untraditional approach to how to do evaporation. Today we have a product range of 6 different evaporators and 2 different technologies. I'll take you through our first and prime technology. Was mechanical vapor recompression, and we optimized that process with full extent, so that we are able to evaporate 1 liter of water for about 8 to 10 watt-hour per liter. That's very, very low. To give you an example is that the energy you use at home on your stove will be 836 watt-hour per liter, meaning that we do that 83.6 times better than that, at least. So where to use that kind of technology? Well, you could use it for something that has very little value, for instance wastewater. So that's where we started. We started with selling these machines to people who have wastewater problems, having problems with getting rid of their wastewater, having to pay high fees in order to get rid of it. Typically the fees for wastewater containing a little bit of oil is about 650 Danish kroner per cubic meter, or in euros it will be around 85 euros per cubic meter to get rid of it. If there's a slight hint of heavy metals, it could be nickel, zinc, chromium, cadmium, or any kind of heavy metals in the wastewater, you pay up to almost 2,000 Danish kroner per cubic meter, meaning that's about 200 to 350 euros per cubic meter. Is ET40, which gives 40 liters the hour. We have an ET 350 liters the hour. We have an ET 500 liters the hour, and we have an ET 1000. It's 1,000 liters the hour, and now also an ET 2500, 2,500 liters the hour. Besides that, we also now have come up with the idea that we should make evaporation something that was even more simpler to produce, one thing, but the other thing would also be that how do we downsize evaporation, and how do we make, let's say, how do we make the Lego of evaporation? How do we become the Lego of evaporation? And so we came up with the compact concept, which is all about putting a lot of parts together, valves, compressors, evaporating heat exchanger, and all these different parts, put them together in one unit with one motor. And that is what we have done with the compact. Create a wastewater gadget unit that could clean ordinary wastewater. Alright, here we are. Yes. Alright, we are ready to install the floor sweeping machine. That's just emptied out its dirty water. And we'll start with hooking up the air. Then we will put in the suction side of the... I can just have a quick glance in there. It's really, really, really dirty, this corner. Like that. Then we attach the suction set. Then we have the distillate here. That's where the clean water should go. Yes, and then of course electricity. A little bit of me and a whole lot of you. Alright, that's it. So let's cook it. All right, ready to go. Now we just have to wait for about 1 hour until it has heated up, and then it dries continuously. Well, let's wait and see how it goes. All right, what we're gonna try now is to measure, before we measure at the machine, to measure the conductivity of tap water here in this area. This area is Nordborg, Denmark, Danfoss area. And so just a good way to easy evaluate the pollution or the contamination of water is just to measure the conductivity. And usually, to my experience, in this area the conductivity is about 400. This one says about, yeah, it will probably end around 400. So let's try to go to the machine and look at how the distillate looks there. Alright, so what we're going to do now is we're going to simply measure the conductivity of the clean water that is right here. And I guess the bottle was a little bit too small, so I'm just going to fill in a little bit of clean water the machine's made. So there you go. And try to see what is the conductivity. And this is happening. Looking at it, I don't know whether you can see it, but this is actually very clean water. We have 32 in microsiemens, and the tap water is around 400. So it means that this is very clean water. This is distillated water, by the way. So, and distillated water you can actually use in machines like this, because if you use distillated water instead of just ordinary tap water, you are able to use less soap. So the overall total cost of ownership, so to speak, will fall on this machine if it would use distillated water.